Let's see another binary tree problem from LeetCode. This is binary tree maximum path sum, and this is a hard problem. Let's try to understand first, and then we'll find a strategy to solve this. So here we need to find maximum path sum. So if you just find the path and all the possible path and get the maximum and returns that. So here there is only one path, 1 2 3, and then output the sum is 6. If you see this example, there can be multiple path. This can be one path, this can be here one path, this can be another path, or this can be another path. So we need to return the number that says that's a maximum path. So that's the problem here. If you see in this example, output is 42. So 42 because this path has maximum value. Okay, so that's the problem is clear, and we need to find out a strategy how to solve this. So we need to keep like 3 rules here for this. One of the rule is, we traverse to the left, most left and the most right. So we traverse that, so we need that depth first search. So we're going to traverse this one, and then when we traverse, we need to second thing we need to find out the max of each node, or we can say max of each path. So if I come here 9, so here also there are 2, the one is left and the right, but that is the nil. So if you, this is the left is nil and here right is nil. So if you see the max path, we can say this 0 0 plus 9. So that's the max path, and max path is 9. In the similar way, if you come here for the 15, this node, from this node the max path is 15. So 0, not a 0, but you can say the max of this left and right, and then plus 9. So if you come here and if you say like which one is the max path, then what we do, we get the max of this 2 node and then plus this. So 15 plus 20, 35. So 35 will be the max here. So we keep updating the max. In that way, at least we know, we'll know that whether this is the max path, because the max number will be here. So we'll calculate this thing from the bottom. So that's the second rule, and the third rule, or third and the last rule, is as we go to the each node, we need to find out the maximum, the path value. So there is a global variable, and we'll use the global variable, and we also keep updating what is the max. So for the max, if I say for this path, if I say the max, then I need to add this. So 1527, I need to add this. So that's the max path. So that's the max value I can calculate. So that is the third rule. But in a second rule, maybe this is not the max. Maybe maybe this route was max. So for that we need to update this max value. That was the second rule. So let's write the code and we'll understand clearly all about the 3 rules. So the let me define one helper function here. And here I want to pass one result. So the subtype is pointer, and this is going to return the int, and here I'll put result variable. So result is, I'll just put the lower value, so math dot mean int, and we can call this function here. We can pass the root and we can pass the result. Okay, so our logic starts here. First we'll check for the nil. Root, if root is equal to nil, then return 0. Okay, so we check that. Our first rule is we do the depth search, depth traversal. So we'll do that. So that's the first rule. So let's call this thing. And root dot left, and we can pass result. Again we can call for the right. So that's the first rule. First rule is to go depth in a left and in a right side. So we traverse in a left and right side. So that's a depth first search. So that's the first rule. Let's and what it returns, like as we traverse here and when we reach and at the end of the node, then it will return the max of that, like left and right and the plus this. So that's it's going to return. So we can put that return. We need a one max function also. Let's create the max function. Okay, so this is going to return this node. So root dot val plus max of root dot left val plus root dot right or we can just say left and right, and this is, you can put it here left, and here we can put the right. So it's the first time, like when we traverse, it will go to the most left, so we'll come here in this place, and from here once it reach here, then it will go to the left, and left it finds nil, so root is nil, then return 0. So this will return 0, so that value will come here, and then again after left the right will also call, so right will also be 0, so right will be here 0, and that's why I'm saying root val is 9, and then 0 max of this left and right. So 0 max of 0 is 0. So for this it will return the 9 because root dot value is a 9. So this is going to return 9. In the similar way, for this the left is, the left is 9, and then again it will call for the right, so it'll go to the most this left here in the right, and then come to this left. Again for this it will return the 0 plus 15, then 15. So that's for that I just put that left right, and in this place it will return the max of this 15.7 plus 20, so root value. So for each node it's returning the max for these triangle things. And also we need to calculate the the result. So we need to find out like which is the max path also. So for that we can add the logic here. Star result is equal to max of star result, and then we can add these three values. So root dot val plus left plus right. So we could keep updating this result, and here we can return the result. That's the pointer where we are passing. So for the pointer I can just pass the address here. So this is the main logic. One of the corner case, for this is we need to handle like if there are 3 nodes on the triangle, and let's say this is the negative number, then even though if you want to find out like which is the max, then we need to know this is the max, so we can replace with this 0. So for that we need to handle that logic here. So in this place I can just check max 0 comma this thing, and also this place max 0 comma this. So this will handle the negative value. So that's all. Let's run this. Okay, we can see in the Java solution also. So the logic is exactly same here, and you can see the first we handle the null, and then we're calculating this left and right max, this node. So all these node we are calculating with this logic, so left max and right max, and this is the logic about that, like calculate this max, come here and find the max route, so max path here, and this logic will keep updating or the max result here. So let's dry run one more time. So for this example, like let's say we call max path some helper, we call this function, and then it's the left and right. So from here it will go left, and the right is still pending. So first left will finish and then come to the right person. Again from the left, call the left here, that returns 0 because that's a nil. Right returns 0, and then it will, the left value will be 9. So left value will be 9, and then the right will get called now because that was pending, so right will get called, and for this right value again this left will call another call for the right, and from this place, here again left and the right will call, and that will be the 15, so it will return the 15. So but in between also it will calculate the max also. So let's see, like when we are here and when it return the 9, like left return 0, this left, and this right return 0, then for this left things, left's done and the right also done, then the result we calculated, we updated 9 is the max. So we put that because this root value plus left plus right, so left, right, and this 9. So we put the result here. Again we came to this place, again here in this place. So when it returned the left and right 0 0 for this 15, then again we check what is the max, so we calculated this result. So result and root value, so for this root value is 15 plus left and right, so 15. So we updated the result 15. In the similar way, when we come to this place, we calculate it again, this triangle value, and put that in a result. So we find the max of that result, and we find this is the maximum path. So that's the three step we need to remember. We just traverse and then return for each node. This is the left and right max plus this value, keep returning that, and in the result, when we calculate the result, third rule is each triangle just put the max, update the max, and that's all. So that's all for now. Thank you.